So far, you've run full hypothesis tests for both means and proportions. And in these tests, you had to make decisions on the null hypothesis either to reject or fail to reject it. And we've assumed all along that these decisions that you made at the end of these tests were legitimate and, in fact, true. But what if they weren't? If you recall, we ran into the same type of situation with our other inference technique, confidence intervals. When we had a 90% confidence interval, we knew that if we had, let's say, 10 intervals that we created, 9 of them would catch the true population parameter, whether that was mu or p. But remember, that also meant that 1 out of 10 would not, because we can never be 100% confident in our results because we're making an estimation. Well, it turns out that in hypothesis testing, we run into the same type of scenario. When we make a decision in terms of a hypothesis test, sometimes it's right, sometimes it's not. So the best thing to do here is do a deep dive on all the types of decisions that can be made in a hypothesis test. It turns out that there are 4 of them. The first 2 of these decisions are based on one thing. We must assume that the null hypothesis is true in reality. So here's an example. A previous problem that we did, I believe a college claimed that the commute time was 9 miles for their students, right? So what would we be doing in that example? We would say that the commute time is in reality 9 miles. So before you even run the test, you know that this is true in the real world. So what are the 2 decisions that can be made at the end of a hypothesis test? Well, you could fail, let's go back to red here, fail to reject, H0. So let's say in the hypothesis test, this is what happens. You fail to reject it. So what does that mean? That means if you fail to reject this, then you are siding with it as being true. Well, if it is true in the real world, now you run a test. And by the way, the test doesn't know whether it's true or not. The test is just math. You guys know that, right? You know that when you calculate the test statistic and do either the critical value or p-value method, it's all mathematics. The test doesn't have eyes. It doesn't know what's true or not. It's just going by the math. So now, in this scenario, we're basically saying that the math has led us to fail to reject H0. And if the H0 is true in reality, then we're making the correct decision. This is the most ideal outcome of a hypothesis test. H0 is true, and the test has also stated that it is true. But again, the test doesn't have eyes. It only knows the math. So what if we run the math, the numbers, and we end up rejecting H0 in that test? That is a problem because this is true in the real world. We've already just said that that's what we're assuming. So if we end up rejecting that, we're basically tossing it away and siding with the alternative. That is the wrong decision. So this is an example of when a hypothesis test basically goes wrong. It's making an incorrect decision. Whenever we reject a true null hypothesis, we call this a type 1 error. Okay, so far we've covered 2 decisions, 1 and 2 right here. So we need to cover the other 2 decisions, but these 2 decisions are based on the opposite scenario. So let's assume that in the real world that this is completely false. So the college came out with this as a number, but maybe they made it up. I don't know. It is indeed not true in the real world. So again, we run the test. The test is just math, and we end up failing to reject H naught? Okay, so if we fail to reject H naught, that means, as we stated up here, that means that we are siding with the null hypothesis. But the problem here is, in the real world, that is false. That is not true. So therefore, you're actually making the wrong decision, but a different wrong decision. Specifically, this is failing to reject a false null hypothesis. Whereas this one up here, this guy right here, was rejecting a true null hypothesis. This is failing to reject a false. That's different. This is called a type 2 error. Our last decision possibility is that the test in this scenario of assuming that the null is false is to reject H naught. So basically, we know this isn't true. And now the test says to reject it, which means we're making the right or correct decision. Again, this is what we want to happen in our test. We want to make the correct, obviously, we want to make the correct decision. Now you've seen all 4 scenarios of what could happen in a hypothesis test based on whether the null is true or not in the real world. We clearly have 2 correct decisions here and here, and 2 errors that could develop from a hypothesis test. The next logical place to go now is to talk about probabilities associated with these errors. So first one, our type 1 error. The probability of a type 1 error is actually equal to alpha. And yes, this is the same alpha that you are provided at the beginning of every hypothesis test, specifically the significance level. So before you start any hypothesis test, you already know the probability of committing a type 1 error before you even go in. So that is always going to be alpha. Similar, a type 2 error, the probability of such, will logically be the next letter in the Greek alphabet, which is going to be beta. While you will know alpha at the beginning of every problem, you will not know beta. Beta is a completely separate computation, and it's a bit more complicated. It's something that is usually done in the second course of statistics. You will not know it here. That being said, there is a very important relationship that occurs between alpha and beta. Specifically, that they are inversely related. So what exactly does that mean? That means that if you decided to increase the probability of a type 1 error occurring, then that would result in the probability of a type 2 error decreasing. Whereas if you decided to decrease the probability of a type 1 error, for example, if you changed your significance level from 5% to 1%, then what would that do? That would increase the probability of a type 2 error. Why is it important to know that they're inversely related? Because in the context of the problem, the wrong decision that you're making could lead to drastic results that you never would want to happen. So just as an argument, let's just say the type 1 error is very drastic and you would never want it to actually happen. Then you would likely try to decrease that as much as possible. But the problem is by decreasing that type 1 error probability, you're actually increasing whatever the type 2 error in context would be. So this is a decision that statisticians have to face. They have to balance out. I call it kind of the seesaw effect, like a seesaw with 2 people on it, right? I need to give these people arms. I always forget that. The balancing act of deciding which one is better to be lower for the sake of the other one being higher, or trying to keep them in a similar balance, that is an important decision that statisticians have to make. Right now, most of what you see here is all things that are not in context. I know I use this example of this 9 mile stuff at the top in order to give it some context, but it's kind of hard to really see and feel the impact of the balancing act of these decisions unless you see like a really solid example. And that solid example actually falls within the legal system, specifically jury verdicts. So what we're going to do is we're going to set up a hypothesis test that basically mirrors a jury court case. So basically, we consider a current defendant in this court case. Normally, unless there's an obvious witness or like video, whatever it is, the only person that really knows whether they're guilty or not for sure is the defendant. So what we're going to do is we're going to have a null hypothesis, as you see here, that will be that the defendant in the course is not guilty. Whereas the alternative is, well, the alternative is that they are guilty. Now this is going to represent the real world truth of the guilt of the defendant, basically. We also need to set up how the jury works. So at the beginning of a hypothesis test, we state the null and alternative. At the end, we make a decision, or the hypothesis test makes a decision, on whether you reject or do not reject the null hypothesis. So that's exactly what we're going to do. So we're going to define failing to reject the null hypothesis as not guilty. This makes sense because the null hypothesis is that they're not guilty, and if you're failing to reject it, you are siding with that. Whereas rejecting the null hypothesis is going to be that they are guilty. Same idea. If the null is that they're not guilty and we're rejecting that, we are saying that they are guilty. So this is going to be the jury verdict. So the thing that we need to do now is we need to simulate these 4 decisions in this scenario. In other words, in this courtroom with this jury, we need to decide what these decisions are, what they look like, and what are the ramifications for those decisions. Some of these ramifications are going to be pretty intense. What I've done to save time is I've sort of created this little print up here that will allow us to get through this a little quicker and save some video time for students and a lot less writing. So similar to last time, what we're going to do at the beginning of this right here is we're going to assume that the null hypothesis is true. So if the null hypothesis is true, then what do we know in the real world? We know that the defendant in this court case is innocent. They are not guilty in the real world. Now, again, when you go into a court case, the jury does not know this. Only the defendant really knows. So the jury is left to use all the things that come up in the court in order to make their judgments. If you think about it, the jury is a lot like the hypothesis test. The hypothesis test uses math, whereas the jury is going to use deliberations in order to determine what the result is going to be. But the defendant who's sitting there, based on this assumption right here, is indeed innocent in the real world. Before we get started with our decisions here and here, just let's talk about what the ideal verdict is here. So what do we want to happen? Well, if we know if the defendant is truly innocent, then in both of these scenarios, we really want this to come out not guilty. The defendant is innocent, so of course we want it to be not guilty. We want this to make the correct decision. But as we have stated, that doesn't always happen, and it doesn't happen in the real world either. So let's take a look at these decisions. Our first decision is to fail to reject the null hypothesis. Now, we have already defined failing to reject the null as not guilty. So the verdict is not guilty. Okay, if you look at our scenario here, we have an innocent person where the ideal verdict is not guilty. The jury has come through and said they're not guilty, which means we have a correct decision. This is exactly what we want the jury system to do. It's to make the correct decision. And in this case, it's the same thing with the hypothesis test. We wanted to make the correct decision. So hopefully you can see the mirroring of these two concepts that really works out well. Now, just note, what does this mean in the real world? This just means that an innocent person is set free, which is exactly what we want. But the jury might not actually come up with the verdict they just did. What if they decided to reject the null? Well, we've already defined rejecting the null as guilty, which means the jury verdict here is guilty. What's happened? They've made the incorrect decision. So just like a hypothesis test that can make an incorrect decision, the jury can as well. More mirroring going on here. So what's the ramifications of that? An innocent person is going to jail. We'll just assume for argument's sake that this is a jail time type of criminal offense. So, one small thing, you obviously saw that we have that is not a great outcome, right? Innocent person going to jail, not at all. But we want to make sure that we identify what wrong decision this is. So remember, if you reject a true null hypothesis, then that is called a type 1 error. For our next scenario of two decisions, we are going to assume that the null is false. And what does that mean? That means that if this is wrong, we're siding with this, and that this person is indeed guilty. So this person is sitting in the courtroom. They are guilty as sin for what they did, and now it's up to the jury to actually send them to jail for it. So just to be clear, the ideal verdict for a guilty person is, of course, for the jury to follow up and say guilty. But let's talk about our decisions. Suppose we fail to reject the null hypothesis. If we fail to reject, according to our decision, we are setting a not guilty verdict. This is the incorrect decision. What are the ramifications now? A guilty person is going to be set free. So my hope is when you read that, you immediately internalize that and think, man, that's not good either. That's terrible in terms of an outcome. So one small thing, remember, if we fail to reject a false null hypothesis, we call that a type 2 error. Okay, our last decision. Let's say we reject the null. Remember, rejecting the null is a guilty verdict. So we have made the correct decision, or the jury has, which means the guilty person is going to jail. This is exactly what we want to happen in the jury system and in a hypothesis test. So these are our 4 decisions, 2 correct and 2 incorrect. So I just want to be pretty straightforward with the reason why I did this, not only to give you a little insight into how the jury system can mirror hypothesis testing, so to give it a face, so to speak, but also to understand the ramifications of a type 1 error versus a type 2 error. So remember, you need to increase one to decrease the other. So the real question here is, Like, what would you prefer? Would you prefer for an innocent person to go to jail or for a guilty person to be set free? I ask this question all the time in the classroom, and I get people that answer one or the other in terms of their preference. But I don't know if there's any real right answer to this. They're both terrible options. So, can you imagine a statistician trying to decide which one of these is going to go up so the other one goes down? That does not sound like a good thing to have to do, right? So I wanted to give you something that sort of is kind of emotionally invested, like something that you really could look at and be like, that's terrible. Well, that is what these decisions could do, and the reason why setting their probabilities is usually a pretty powerful thing that statisticians have to figure out. Now that you've seen these two errors, type 1 and type 2, in context, the one thing we really haven't covered is what this would look like in a homework problem or a test. Like, what exactly am I answering? Like, a student might say, what am I writing here? Well, we're going to do exactly that. Let's do an example and see the best way basically to answer a problem that's asking for a type 1 or type 2 error. It says the manufacturer of rock climbing equipment is currently in the product testing stage of production or development. Assume the following set of hypotheses about the safety of the new equipment. Our null hypothesis is going to be the rock climbing equipment is safe. Our alternative is that it's not safe. Remember, this represents the real world truth of each of these scenarios. Okay, before we get started with this example, because we're going to, in a second, we're going to basically determine what a type 1 error is in this setting, and of course a type 2 error. Before we do that, we want to make sure that everybody is clear on what each one of these things means. So just as a review, so a type 1 error means to reject a true null. So in other words, we have something that is true in the real world, but then the test that you run, that's based on math, remember, it doesn't have eyes. The test that you run decides to reject it. That's, of course, a bad result. We don't want to reject something that's true, right? So what's a type 2 error? That is fail to reject a false null. So again, we have a null that is not true in the real world, but we fail to reject it, which means we're siding with a null hypothesis that's incorrect. That again is a incorrect decision, something we don't want to happen. So my suggestion is to basically memorize these two statements so that you know what a type 1 and 2 error is. Then what we're going to be doing in the problems themselves is we're going to be putting these statements in context with the null and alternative hypothesis. So how do we do that? Well, let's look at the type 1. My suggestion is to always start with the true nature of the null hypothesis. So whatever the truth is, whether it's true or false, start with that. So for example, you could say, in this scenario, what would a true null hypothesis in the real world mean? That would mean that the rock climbing equipment is safe. So we start with that. We would say the rock climbing equipment is safe. So this is a statement of truth about the null hypothesis. But the test concludes. Well, what does it conclude? Well, we are rejecting that it's true. So the test is concluding that it is. So it's rejecting this, which means we're going to side with this. The test concludes that it is not safe. Okay, this is exactly a type 1 error in this setting. Again, the key is being able to take this statement and apply it to the null and alternative hypothesis. I just gave you a foolproof way to do so with this example, in which you basically just start with whatever the true null is, and then make a statement about what the test concludes. And that usually will get it done for you. So let's try doing that for a type 2 error. So if we start with the truth of the null, which in this case, that it is false. So if this is false, that means this is what we're determining. So we would say right off the bat that the rock climbing equipment is not safe. But the test concludes. So what does it conclude? Well, we have failed to reject the null, which means we are siding with it. We are accepting it. So that means the test's decision is that it is safe. So this is the perfect way to make this statement here, this type 2 error, in context with our null and alternative hypothesis. Okay, so before I end the video, again, let's look at these ramifications. So remember, we're talking about the seesaw, right? The seesaw. So if one of these errors is increased versus the other one's going to be going the opposite direction. So let's figure out which one of these is worse, and then that will be the one we want to make sure the probability is low. So the first one says the rock climbing equipment is safe in the real world, but the test concludes that it's not safe. Well, if the test concludes that it's not safe, then basically they're not going to sell it. So according to this, we have safe equipment that's not going to be sold because the test has made the wrong decision. So who does that hurt? That hurts the company. The company's going to lose money. They're putting out safe rock climbing equipment, but then some test has made the wrong decision, and all of a sudden they can't sell it. So clearly that's not great for the company, right? But before we go and decide that that's terrible and needs to be a lower probability, let's look at the other scenario. So the other scenario says that the rock climbing equipment is not safe in the real world. So something's broken in there, but the test concludes that it is. Okay, this doesn't look good, folks. So if the test concludes that it's safe, that means it's going to be sold. And if the rock climbing equipment is not safe in the real world, you're actually selling faulty equipment that's going to be used on the side of a mountain. So this could result in injury or even worse, which means this, as much as I feel bad for the company losing money, this is definitely going to be the one, very clearly, that's going to be at a lower probability. Now remember, there's the seesaw relationship between type 1 and type 2 errors. So in this scenario, we're going to want this one to be the type 2 error, and even though that might increase our significance level, alpha, to 10% or whatever it's going to be, we need to keep that type 2 error low because we might have some really strongly poor ramifications to deal with here. So note that on exams, I usually make sure, if I ask you for ramifications and I ask, hey, which one of these should be low? It's really clear which one should be low. Like this example. Like, unless you're a sociopath, you're going to pick this one as the one that is going to be the worst one, right? So therefore, no offense to the sociopaths. So unless that's the case, I wouldn't use an example like this because, you could be really split on your opinion on which one of these is worse. I try not to do that. I try to pick ones where it's very clear in which the decision is going to be made.